The telescope is designed to look back in time. Because light travels at a finite speed, looking at distant objects is always a form of looking into the past. Webb is a telescope designed to maximize this effect. By being so sensitive to the faint, ancient light of the most distant galaxies, it is able to see the universe as it was in its infancy. It is a powerful and peaceful time machine, allowing us to quietly witness the first chapters of the cosmic story as they were being written. It is the most powerful and complex space observatory ever built. The James Webb Space Telescope represents the culmination of decades of work by thousands of scientists and engineers from all over the world. Its mirror is 7 times larger than Hubble's, and its instruments are 100 times more sensitive. It is a monumental achievement of human curiosity and ingenuity, a quiet and beautiful machine built for the sole purpose of peacefully and gently expanding our understanding of the universe. Its journey to its final orbit was a month-long silent voyage. After its launch, the telescope spent 30 days traveling through the quiet, cold darkness of space to reach its final home at the L2 point. During this long and peaceful journey, it slowly and gracefully unfolded its complex structures, cooled down to its operating temperature, and prepared itself for its long mission of discovery. It was a month of quiet and patient anticipation, a slow and serene pilgrimage to its final, lonely, and perfect observing post. The James Webb Space Telescope has seen some of the very first galaxies to ever form. In its very first deep-field images, Webb peered back through the immense corridors of time to a period when the universe was just a few 100 million years old, a quiet, young infant. There, in the deep, cosmic dark, it found the faint, reddish smudges of the very first collections of stars to ever light up the cosmos. These are the quiet and gentle seeds from which all later galaxies, including our own, would eventually grow. It has found galaxies that are older than we thought possible. The first galaxies that Webb has seen are a beautiful and serene puzzle. Many of them appear to be brighter, larger, and more well-structured than our theories had predicted for such an early time. The universe, it seems, became a place of order and complexity very quickly after the Big Bang. These quiet, ancient objects are gently asking us to rethink our story of the universe's dawn. These first galaxies are like tiny, red smudges of ancient light. In the stunningly deep images from Webb, these record-breaking galaxies are not grand and majestic spirals. They are incredibly small and faint, often just a few pixels across. Their reddish color is the result of their light being stretched by the expansion of the universe for over 13 billion years. They are the quietest and most humble of objects, yet they hold the grand and profound story of our cosmic origins. We are seeing them as they were over 13 billion years ago. The light from these first galaxies began its journey to us when the universe was less than 5% of its current age. For all that immense stretch of time, while our own solar system was yet to form, while life on Earth was yet to begin, this faint and ancient light was traveling silently and peacefully through the expanding void, a quiet and patient messenger from a long-vanished epoch. Some of these early galaxies are surprisingly bright and well-formed. The quiet efficiency of the early universe is a beautiful mystery. Our models suggested that the first galaxies should be small, clumpy, and irregular. But Webb has found galaxies at this early time that are already showing the beautiful, orderly structure of a rotating disk, the same serene shape as our own Milky Way. It is as if the universe learned the art of building beautiful, peaceful galaxies very early in its life. The telescope is gently challenging our ideas about how the universe began. Every new image of the deep universe from Webb is a quiet and beautiful revolution. The surprising maturity of these first galaxies is forcing astronomers to reconsider their models of star formation and galaxy assembly. It is a gentle and peaceful process of discovery, where each new, quiet picture helps us to refine and deepen our understanding of the cosmic story. A galaxy named JWST 13 is one of the most distant objects ever seen. This unassuming name belongs to one of the current record holders for the most distant galaxy. We are seeing it as it was only about 325 million years after the Big Bang. It is a tiny, quiet object, a single, faint candle burning in the immense darkness of the cosmic dawn. To see it is to look upon one of the very first seeds of cosmic structure. Its light traveled for 13.4 billion years to reach the telescope's mirror. The journey of the light from this single, small galaxy is a story of profound and quiet patience. For an almost unimaginable stretch of time, its photons traveled across a universe that was growing and changing, passing through the voids and filaments of a cosmic web that was still in the process of being built. Their long and lonely journey ended in a quiet and gentle moment of arrival on a golden, hexagonal mirror. These ancient galaxies are the quiet ancestors of our own Milky Way. The grand, majestic spiral galaxy we call home was not born in its current form. It was built up over billions of years from the slow and gentle mergers of many smaller, more primitive galaxies, just like the ones Webb is now seeing. To look at these distant reddish smudges is to see a quiet and beautiful photograph of our own galaxy's great-great-grandparents. The telescope is searching for the very first generation of stars, known as population 3 stars. These are the theoretical first stars to have ever existed. They would have been born in a universe that contained no heavy elements, only the primordial hydrogen and helium from the Big Bang. They would have been colossal, brilliant, and very short-lived. Webb is so powerful that it may be able to see the combined faint glow of the galaxies these first stars built. It is a quiet and gentle search for the universe's very first lights. These first stars were made of only the simplest elements from the Big Bang. A star like our Sun is rich in carbon, oxygen, and iron, elements that were created in previous generations of stars. But the very first stars had no such inheritance. They were formed from the pure, clean, and simple gas that filled the early universe. Their lives and their deaths were the quiet and gentle forges that created the very first heavy elements, beginning the process of cosmic enrichment that makes planets and life possible. The early universe was not empty, but filled with a thin, neutral gas. After the Big Bang, the universe cooled, and the protons and electrons combined to form a vast, dark and transparent fog of neutral hydrogen gas. This period is known as the Cosmic Dark Ages. There were no stars, no galaxies, just a quiet and simple ocean of invisible gas, waiting patiently in the darkness for the first lights to turn on. The light from the first galaxies helped to clear this cosmic fog. The intense ultraviolet light from the first generation of hot, young stars began to ionize the neutral hydrogen gas around them. This process, known as reionization, created expanding bubbles of clear, transparent space in the cosmic fog. Over hundreds of millions of years, these bubbles grew and merged until the entire universe was once again transparent to light as it is today. It was a slow, quiet, and gentle cosmic dawn. We are living in the era of reionization, a time made possible by these first lights. The clear, star-filled universe we see today is a direct result of that ancient, transformative era. The quiet and patient work of those first, long-vanished stars and galaxies is what made our transparent cosmos possible. We are living in the peaceful and serene aftermath of the universe's first Great Awakening. The telescope has found ancient galaxies that are shaped like disks, much earlier than expected. The beautiful, flat, spinning disk of a galaxy like ours is a structure that we thought took many billions of years of quiet and gentle evolution to form. But Webb has found galaxies with this same serene and orderly shape existing when the universe was just a fraction of its current age. It seems the universe learned the quiet art of building graceful, spinning structures very early on. The universe seemed to become orderly and structured very quickly. The discoveries from Webb are painting a new and beautiful picture of the early cosmos. Instead of a chaotic and messy place, the early universe seems to have been surprisingly efficient at creating the kind of large, orderly, and peaceful structures that we see today. The quiet and fundamental laws of physics appear to have a built-in preference for creating serene and beautiful patterns. Each ancient galaxy is a quiet, gentle clue to the story of cosmic creation. Every faint red smudge in a Webb deep field image is a precious and profound piece of information. Each one tells us a little more about the conditions of the early universe, about the nature of the first stars, and about the quiet and patient processes that led from the simplicity of the Big Bang to the rich complexity of the cosmos we inhabit today. They are the quiet, gentle words in the universe's oldest and most beautiful book. Hello there, and welcome to the Dozing Explorer. I'm so glad that you have found your way to this quiet harbor in the vast cosmic sea. There is nothing at all you need to do now but to settle in, to find a position of perfect comfort, and to allow the weight of the day to gently release. My voice is here to be a soft and steady guide on a journey into the newest and most profound wonders of our universe. Tonight, we will drift into the silent, ancient light being gathered by the James Webb Space Telescope. We will not be studying astrophysics or complex data, but rather wandering through the beautiful, ghostly images and the quiet, gentle discoveries it has sent back to us. This is a journey to the very dawn of time, a quiet exploration of the first stars, the first galaxies, and the serene, hidden worlds that orbit distant suns. We will think of this telescope as a time machine powered by patience, a golden eye designed to see the universe's oldest and most gentle whispers. We will float through cosmic nurseries where stars are being born, and we will visit the serene, expanding clouds of stars that have long since ended their lives. We will listen for the chemical signatures of water in the air of planets 1,000 light-years away. This is a story of looking back, of seeing the universe not as it is now, but as it once was, a quieter, younger, and more mysterious place. It is a peaceful journey to the very edge of our understanding. And just before our journey begins, if these quiet explorations help your mind to find its rest, please consider liking and subscribing. It is a silent gesture that helps other sleepy souls and curious minds find their way to this quiet harbor, ensuring our gentle voyages can continue. But for now, all of that can fade away. There is nothing to remember, nothing to solve. Your only task is to rest, to breathe in and to breathe out, settle in, get comfortable, and let our journey begin. Your mind has full permission to wander, to drift, and to fall completely and deeply asleep whenever it feels ready. A telescope's giant golden mirror is designed to capture the oldest light in the universe. The heart of the James Webb Space Telescope is its vast and beautiful primary mirror, a honeycomb of 18 perfect golden hexagons. This mirror is not just for seeing, but for gathering. Its purpose is to collect the faintest, most ancient photons of light, particles that have been traveling across the expanding void for over 13 billion years. Gold was chosen for its surface because it is exceptionally good at reflecting the very specific kind of old, tired light called infrared. It is a great, silent net patiently waiting to catch the first gentle whispers of the cosmos. It has a sun shield the size of a tennis court to keep it perfectly cold. To see the faint, infrared heat of the distant universe, the telescope itself must be incredibly cold. To achieve this, it flies behind an immense and delicate sun shield. This shield, made of 5 layers of a thin reflective material, is as wide and as long as a tennis court. It is a vast silver kite, permanently angled to block the light and heat from the sun, the Earth and the Moon, creating a perfect, profound shadow in which the telescope can perform its quiet and sensitive work. The sun shield has 5 layers, each one cooler than the last. The sun shield is a marvel of gentle and passive engineering. Each of the 5 layers is separated by a vacuum, which is a perfect insulator. The first layer, facing the sun, gets quite warm, but it reflects most of that heat back into space, and the small amount that passes through is then reflected by the second layer, and so on. With each successive layer, the temperature drops dramatically until the final layer on the telescope side is cooled to a state of profound and peaceful cold. It is a quiet, multi-layered parasol, creating an island of deep Arctic chill in the warm glow of the solar system. The cold side of the telescope is colder than any freezer on Earth. The temperature in the shadow of the sun shield is almost unimaginably cold. The telescope's mirrors and instruments operate at a serene and stable temperature of around -230 degrees Celsius, or 40 Kelvin. This is a coldness that is close to the absolute zero of space itself. This profound chill is necessary to prevent the telescope's own gentle warmth from interfering with the even fainter heat signals arriving from the dawn of time. It is a quiet and beautiful piece of engineering, creating a perfect, silent bubble of absolute cold. The telescope is not in orbit around the Earth, but around the Sun. Unlike the Hubble Space Telescope, which circles our planet, the James Webb Space Telescope was sent on a much longer and quieter journey. It orbits the Sun in lockstep with the Earth, but from a great distance away. This special orbit ensures that the Earth and the Moon are always on the same side as the Sun, allowing the telescope's sun shield to block out all 3 sources of heat at once. It is a serene and lonely orbit, far from the warmth and bustle of our world. It sits at a quiet, stable point in space 1,000,000 miles away. The telescope's home is a special place known as the second Lagrange point, or L2. This is a point of gravitational equilibrium, a quiet and stable valley in the gravitational landscape where the pull of the Sun and the Earth are perfectly balanced. By orbiting this empty point in space, the telescope can maintain its position with very little fuel, remaining a silent and patient observer for many years to come. It is a quiet, cosmic eddy, a perfect and peaceful place for a telescope to rest. Its mirror is made of 18 perfect hexagonal segments. A single mirror the size of Webb's would have been too large and heavy to launch. So, it was built in 18 individual hexagonal pieces, each one a masterpiece of engineering. These segments were designed to fold up for launch and then unfold in space. They are made of beryllium, a metal that is both incredibly strong and incredibly lightweight, and which holds its shape perfectly in the deep cold of space. The honeycomb pattern is not just beautiful, but is the most efficient and stable way to build a large, segmented mirror. Each mirror is coated in a whisper-thin layer of pure gold. The golden shine of the Webb's mirror is not just for beauty. The coating of gold is incredibly thin, only about 100 nanometers thick. A single, small piece of gold, about the size of a golf ball, was painstakingly vaporized and deposited onto the surface of all 18 mirrors. This delicate layer is what makes the telescope so exquisitely sensitive to the faint infrared light of the distant universe. It is a quiet, golden skin, perfectly tuned to the colors of ancient cosmic history. The gold is perfect for reflecting the faint infrared light of the early universe. Light from the very first stars and galaxies has been traveling for so long that the expansion of the universe itself has stretched it out. Its wavelength has been shifted from the visible light we can see into the longer, gentler wavelengths of infrared light. Gold is one of the very best materials for reflecting these specific wavelengths. The mirror is a beautiful and serene tool, its color perfectly matched to the color of time itself. The telescope had to unfold itself in space, a slow and gentle origami. The James Webb Space Telescope was launched folded up like a complex and beautiful insect in a cocoon. Over the course of 2 weeks, it underwent the most complex and delicate deployment sequence ever attempted. Hundreds of motors, hinges, and cables all had to work perfectly to unfold its sun shield, deploy its secondary mirror, and swing its primary mirror wings into place. It was a slow, silent, and perfectly choreographed ballet, a mechanical flower blooming gracefully in the quiet darkness of space. It can see the universe in colors of light that are invisible to the human eye. Our eyes are tuned to a very small and specific sliver of the electromagnetic spectrum, the colors of the rainbow. The Webb telescope sees the universe in a much wider range of infrared light. These are colors that are too red for our eyes to perceive. By looking in these invisible colors, Webb can see through the dense clouds of dust that obscure our view of stellar nurseries, and it can see the faint, red-shifted light from the very edge of the observable universe. It is a quiet and gentle window onto a hidden, invisible cosmos. This infrared light is the light of warmth and ancient history. Everything that has a temperature emits infrared light. Your own body glows gently in these colors. Webb is so sensitive it could detect the faint heat signature of a bumblebee on the surface of the moon. This sensitivity is what allows it to see the faint, residual warmth of the universe's first objects, a heat that has been traveling and cooling for over 13 billion years. It is a quiet and serene form of cosmic archaeology, studying the warmth of the universe's oldest and most gentle embers. Looking at these galaxies is like looking at a photograph of the universe's dawn. To see the light from these first galaxies is to be a direct witness to the moment that the cosmic dark ages came to an end. It is the quiet and profound experience of seeing the first glimmers of light in a universe that had, until that point, been completely dark. It is a serene and beautiful photograph of the very first morning of the cosmos. The red color of these galaxies is because their light has been stretched by the expanding universe. The light from these ancient galaxies did not start out red. It was likely a brilliant bluish-white light from hot young stars. But as this light has traveled across the cosmos for 13 billion years, the very fabric of space it is moving through has been expanding. This has gently stretched the wavelength of the light, shifting it all the way down the spectrum to the deep, quiet, and serene reds and infrareds that Webb is designed to see. The telescope is a quiet time machine powered by the speed of light. The finite speed of light is a fundamental and beautiful property of our universe. It is what makes cosmic archaeology possible. Because it takes time for light to travel, the farther we look, the further back in time we see. The James Webb Space Telescope is the most powerful and perfect expression of this principle, a quiet and serene machine built to peacefully and gently carry our vision back to the very beginning of time. The telescope has seen two galaxies merging in a slow, graceful collision. In one of its early images, Webb captured a stunning view of two distant galaxies in the process of a quiet and beautiful merger. The gravitational pull between them had drawn out long, ethereal streams of stars and gas, creating a serene and ghostly bridge between them. It is a snapshot of the quiet, creative process by which larger galaxies are patiently built over billions of years. These galactic mergers can create beautiful, long tails of stars. When two galaxies interact, their gravity can be a gentle and creative force. It can pull on the stars and gas, creating vast, arcing structures called tidal tails that can stretch for hundreds of thousands of light years. These are not signs of a violent explosion, but are the quiet and graceful result of a slow, gravitational dance that can last for hundreds of millions of years. The Cartwheel Galaxy was seen with a new and quiet clarity. This beautiful and unusual galaxy gets its shape from a direct, head-on collision with a smaller companion galaxy. Webb's infrared view was able to peer through the dust and see the intricate, spoke-like filaments that connect the bright inner ring to the vast outer ring. It revealed the quiet and detailed story of a galaxy that is still ringing like a silent, cosmic bell from a collision that happened millions of years ago. Its shape is the result of a smaller galaxy passing directly through its center. The serene, circular ripple of the Cartwheel Galaxy is a beautiful and direct consequence of a cosmic impact. A smaller galaxy plunged through the heart of a larger spiral galaxy, and the resulting gravitational shockwave expanded outwards, compressing gas and dust and triggering a beautiful circular wave of star formation. It is a quiet and perfect circle drawn by the gentle passage of another world. The telescope peered through the dust to see the galaxy's glowing skeletal structure. Visible light telescopes see the Cartwheel Galaxy as a clumpy and obscured object, but Webb's infrared eyes can see the warm, gentle glow of the dust itself. This revealed the fine, beautiful, and delicate filamentary structure of the galaxy's skeleton, the underlying pattern of gas and dust from which new stars are being born. It is a quiet and beautiful X-ray of a galaxy's soul. Webb has revealed the oldest barred spiral galaxy ever seen. The beautiful straight bar of stars that crosses the center of many spiral galaxies, including our own, was thought to be a feature that took a long time to develop. But Webb found a perfectly formed barred spiral galaxy that existed when the universe was only a quarter of its current age. It is another quiet and gentle clue that the universe was capable of creating serene, beautiful, and complex structures much earlier than we ever thought possible. This shows that the beautiful spiral arms of galaxies formed very early in cosmic history. The serene and graceful spiral arms of a galaxy are one of the most beautiful forms in the cosmos. Webb's observations are showing that these structures are not a modern invention of the universe, but an ancient and fundamental pattern. The quiet, self-organizing principles of gravity and motion were creating this beautiful, peaceful order from the universe's earliest and most formative years. A galaxy's central black hole seems to grow in a quiet partnership with the galaxy itself. Webb is studying the supermassive black holes at the hearts of distant galaxies. Its discoveries are reinforcing the beautiful and serene idea that the black hole and its host galaxy grow together in a form of gentle co-evolution. The black hole does not dominate the galaxy. Instead, it grows in a slow and quiet proportion to it, a peaceful and symbiotic relationship that lasts for billions of years. The Phantom Galaxy, M74, was revealed as a delicate, ghostly web of gas and stars. When Webb turned its golden eye to this beautiful, nearby spiral galaxy, it saw a level of detail that was breathtaking. The image revealed a perfect, intricate, and delicate network of gas and dust filaments, all gracefully arranged along the galaxy's spiral arms. It was no longer a phantom, but a living, breathing, and serene cosmic tapestry of incredible and quiet beauty. Webb can see the individual stars within nearby galaxies. The telescope's resolution is so sharp and its sensitivity so profound that it can resolve the faint, individual points of light of single stars in galaxies that are millions of light-years away. This is a quiet and remarkable ability. It allows astronomers to move beyond studying the collective glow of a galaxy and begin to study its individual, peaceful citizens, star by star. This allows us to study the life cycle of stars in different cosmic environments. By looking at the individual stars in a distant galaxy, we can learn about how stars are born, live, and die in a place that is very different from our own Milky Way. It is a quiet and powerful tool for comparative astronomy, helping us to understand which parts of the stellar story are universal and which are shaped By the gentle and unique conditions of their local cosmic home, the telescope has seen green pea galaxies, which are small, round and intensely forming stars. These are a rare and beautiful type of galaxy that are very compact and are glowing with a greenish light from the intense radiation of their newborn stars. They are thought to be a quiet and nearby example of what the very first galaxies in the early universe might have been like. Webb's detailed observations of them are providing a gentle, local window into the universe's most ancient and formative processes. The cosmic web, the vast structure of the universe, is being mapped with new detail. The James Webb Space Telescope is not just looking at individual objects, it is a powerful tool for cosmology. By mapping the locations of thousands of distant galaxies, it is helping to chart the immense and serene structure of the cosmic web with a new and profound precision. Each new galaxy whose distance is measured is another quiet and gentle point of light on this grand and beautiful cosmic map. Galaxies are not scattered randomly, but are arranged in long, quiet filaments. The Webb's deep field images beautifully confirm this fundamental picture of the cosmos. As we look deep into the image, we can see the galaxies are not a random spray of dots. They are clustered together in groups and are arranged in long, serene, and beautiful chains and sheets. It is a quiet and powerful visual confirmation of the gentle, underlying structure of the universe. Stephan's quintet, a group of 5 galaxies, was seen in a beautiful cosmic dance. Webb's image of this compact group of galaxies is one of its most stunning. It is a snapshot of 4 of these galaxies locked in a slow, graceful and quiet gravitational embrace. The image is so detailed that we can see the shock waves and tidal tails created by their gentle interactions, and even the faint glow of individual stars and star clusters within them. It is a beautiful and serene family portrait of galaxies in a quiet and intimate cosmic conversation. Stephan's quintet, a group of 5 galaxies, was seen in a beautiful cosmic dance. The James Webb Space Telescope captured a breathtaking image of this famous galactic grouping, revealing the intricate details of their slow and graceful gravitational interaction. The image is a serene mosaic of sparkling star clusters and long, ethereal tails of gas and dust being pulled from the galaxies as they pass by one another. For the first time, we could also clearly see the brilliant, energetic light pouring out from the supermassive black hole at the center of one of the galaxies. It is a quiet and beautiful family portrait, capturing a single, peaceful moment in a cosmic dance that has been unfolding for hundreds of millions of years. The dust in a galaxy is not just empty space, it is where new stars are born. One of the most beautiful abilities of the Webb telescope is its power to see the dust that fills the space between the stars. In visible light, this dust appears as dark, obscuring clouds. But in Webb's infrared view, these same clouds glow with a soft, gentle warmth, revealing their intricate filamentary structures. This glowing dust is the raw material, the quiet and fertile soil from which all future generations of stars will be peacefully and slowly born. Webb's infrared eyes can see the warm, gentle glow of this hidden dust. Because the telescope is designed to see infrared light, which is essentially the light of heat, it can detect the faint warmth of these cool, dusty clouds. This allows us to see the hidden skeleton of a galaxy, the underlying structure of gas and dust that is otherwise completely invisible. It is a quiet and serene form of cosmic X-ray vision, allowing us to see the warm, living bones of the galaxies themselves. The evolution of a galaxy is a slow, patient story that takes billions of years to unfold. The events that the Webb telescope photographs, such as the merging of 2 galaxies, are not rapid or violent. They are processes of immense and quiet patience. The gravitational dance of a galactic merger can take 500 million years from start to finish. We are seeing a single, silent frame from an epic and beautiful film, a quiet and serene story that is being told on the grandest and slowest of all possible timescales. Webb has peered into the heart of stellar nurseries where baby stars are born. Some of the telescope's most beautiful and breathtaking images are of the vast, colorful clouds of gas and dust where new stars are being formed. These nebulae are the quiet and gentle nurseries of our galaxy. Webb's infrared vision allows it to pierce through the obscuring outer layers of these clouds and see the newborn stars, still wrapped in their dusty cocoons, glowing with the soft, gentle light of their birth. The cosmic cliffs in the Carina Nebula revealed hundreds of previously hidden stars. One of Webb's first and most famous images showed what looks like a vast cosmic mountain range with glowing peaks and shadowed valleys. This beautiful landscape is actually the edge of a giant gas cloud, and the cliffs are being carved by the intense radiation from a cluster of massive, young stars located just off the top of the image. For the first time, we could see hundreds of tiny, reddish points of light, newborn stars that had been completely hidden within the gas and dust. It is a quiet and breathtaking landscape of cosmic creation. The pillars of gas are being gently eroded by the radiation from young, hot stars. The beautiful sculptural shapes of these cosmic cliffs and pillars are the result of a quiet and peaceful process of erosion. The powerful ultraviolet light and stellar winds from the nearby massive stars are slowly and gently pushing back the less dense parts of the nebula. It is like a slow, silent wind, sculpting the gas and dust into serene and beautiful forms, a process of cosmic art that takes thousands of years. Within these pillars, new stars are quietly forming. The densest parts of the nebula are able to resist this gentle erosion. Inside these dark, quiet, and protected pillars of gas and dust, gravity is still the dominant force. It is patiently and silently pulling material together, creating the small, dense knots that will eventually ignite and become the next generation of stars. These beautiful pillars are not just being destroyed, they are also the quiet and gentle nests where new suns are being born. The pillars of creation were seen in a new, ghostly infrared light. The Hubble Space Telescope's iconic image of the pillars of creation showed them as dark, solid, and imposing structures. When Webb turned its golden eye upon them, it revealed a new and even more serene view. In infrared light, the dense dust of the pillars becomes translucent, making them look like beautiful, ghostly, and semi-transparent curtains. We can now see the newborn stars glowing like red embers that were previously hidden deep inside. The dense dust of the pillars, which normally hides the stars, was made transparent. This is the quiet magic of infrared light. To visible light, the dust is like a thick, dark wall. But to the longer wavelengths of infrared, it is like a soft, thin veil. This ability to see through the dust is one of Webb's most important powers. It is a gentle and peaceful way of pulling back the cosmic curtains to reveal the quiet, hidden processes of star birth that are happening within. Webb has seen the beautiful hourglass shape around a forming protostar. In one of its most serene and striking images, the telescope captured a newborn star, still in its earliest phase, known as a protostar. The star itself is hidden from view by a dark, edge-on disk of gas and dust that is feeding it. But the light from this hidden star is escaping from its north and south poles, illuminating two vast, cone-shaped cavities in the surrounding gas. The result is a perfect and quiet hourglass of orange and blue light, a beautiful, geometric shadow play created by the gentle light of a star's birth. Jets of energy from these baby stars can be seen shooting out into space. As a young star gathers material from its surrounding disk, it can also launch powerful jets of gas from its poles. These jets travel at hundreds of kilometers per second and slam into the surrounding nebula. Webb is so sensitive it can see the intricate, glowing shock waves created by these jets, beautiful and serene structures that look like a series of gentle, luminous ripples in the cosmic cloud. They are a quiet and beautiful sign of a star's energetic and messy birth. The Orion Nebula was revealed as a stunning, three-dimensional landscape of star formation. Webb's image of the Orion Nebula, the closest large stellar nursery to us, is a work of profound and quiet beauty. It is an image of incredible depth, a vast and cavernous landscape of glowing gas, dark dust, and brilliant young stars. For the first time, we can see the intricate and delicate filaments of gas in 3 dimensions. And we can peer deep into the quiet, dark cocoons where new solar systems are just beginning to form. These are called protoplanetary disks. Around many of the newborn stars in these nebulae, Webb can clearly see a dark, flattened, spinning disk of gas and dust. These are protoplanetary disks, the raw material from which future planets will be made. They are serene and beautiful cosmic turntables, the quiet, spinning nurseries where new worlds are gently and patiently being assembled over millions of years. Webb has seen the dark, shadowy lanes where planets are beginning to form in these disks. The telescope's resolution is so incredible that it can see the structure within these distant protoplanetary disks. In some of them, it can see dark, concentric gaps like the grooves in a vinyl record. These quiet, empty lanes are thought to be the paths that are being cleared by newly forming planets as they orbit their young star, gracefully and silently sweeping up the dust and gas in their path. It is our first gentle and direct glimpse of the serene and quiet architecture of another solar system's birth. The birth of a star is a quiet, slow, and beautiful process of gathering. Contrary to our intuitions of explosions, the formation of a star is a peaceful and gentle event. It is a process of quiet accumulation, where the patient and persistent force of gravity slowly and gently pulls together the diffuse gas and dust of a nebula over millions of years. It is less a bang and more a long, slow, and silent inhalation, a quiet gathering of matter into a new and luminous heart. Webb has seen a protostar in the dark cloud L1527, illuminating a cosmic hourglass. This image gives us a serene and beautiful look at a star that is only about 100,000 years old, a mere infant in cosmic terms. The star itself is still gathering mass, and it has not yet begun nuclear fusion in its core. We are seeing a sun before it has truly become a sun. The beautiful glowing hourglass of light is the quiet and gentle announcement of its impending arrival. The colors in Webb's images of nebulae represent different chemical elements. The beautiful and often surreal colors of a Webb image are not what our eyes would see. They are a form of scientific and artistic translation. Scientists assign different colors, like blue, green, and red, to different wavelengths of infrared light. These wavelengths are often emitted by specific atoms and molecules such as hydrogen, sulfur, or dust. The colors create a beautiful and serene image, but they are also a quiet and detailed map of the nebula's chemical composition. Webb has captured a beautiful and serene image of a dying star. The telescope has also turned its golden eye to the gentle and quiet end of a star's life. Its images of planetary nebulae, the glowing shrouds of dying sun-like stars, are some of its most peaceful and beautiful. These are not scenes of violent destruction, but of a star's final, graceful, and serene act of returning its outer layers to the cosmos. The Southern Ring Nebula is the gentle, expanding cloud of a star like our Sun in its final moments. One of Webb's first images was of this stunning and serene planetary nebula. It revealed 2 beautiful, nested, and expanding shells of glowing gas, cast off by a dying star thousands of years ago. The level of detail was so incredible that scientists could see the fine ray-like filaments of gas and the intricate, bubbly structure of the inner cloud. It is a quiet and beautiful glimpse into the peaceful, eventual fate of our own sun. At the center of the nebula are two stars, a quiet, dancing pair. For the first time, Webb's sharp, infrared vision was able to clearly resolve the two stars at the heart of the Southern Ring Nebula. They are a close binary pair, orbiting each other in a slow and graceful dance. This discovery helped to confirm the theory that many of the most beautiful and complex planetary nebulae are shaped by the gentle, gravitational influence of a companion star. The dimmer of the two stars is the one that created the beautiful, glowing shells of gas. Webb's observations revealed a quiet and beautiful irony. The brighter star at the center is a healthy, normal star that is simply a witness to the event. The true source of the nebula is its much smaller and dimmer companion, a tiny, hot, and dense white dwarf. This is the quiet and serene core of the star that has shed its outer layers, its faint, hot glow now illuminating the beautiful ghost of its former self. Webb could see that the central star is cloaked in a warm, gentle layer of dust. The telescope's ability to see in infrared light allowed it to detect a faint, warm glow directly around the central white dwarf. This is the light of a serene and beautiful disk of dust that was created in the star's final moments. It is the star's quiet and gentle final shroud, a warm and dusty veil that visible light telescopes could never have seen. Planetary nebulae are the quiet, peaceful end for most stars in the universe. While the most massive stars end their lives in spectacular supernovae, the vast majority of stars, including our own sun, have a much more serene and gentle fate. In their old age, they simply and peacefully puff their outer layers of gas off into space, creating these beautiful, glowing, and short-lived objects. They are a quiet, cosmic flower, blooming for just a few tens of thousands of years before fading gently back into the darkness. Webb has seen the remnant of a supernova, a star that ended in a great explosion. The telescope has also studied the more dramatic end of a star's life. Its infrared image of Cassiopeia A, the remnant of a star that exploded about 340 years ago, is a quiet and beautiful tapestry of glowing gas and dust. It looks like a serene and cosmic firework, frozen in a single, silent moment of its expansion. The telescope could see the different layers of elements cast out by the explosion. The different colors in Webb's image of Cassiopeia A correspond to different chemical elements that were forged in the heart of the dead star. We can see the serene, pinkish glow of argon, the gentle orange of sulfur, and the quiet green of oxygen. It is a beautiful and detailed chemical map of the star's interior, a quiet and serene autopsy of a star revealing the precious, life-giving elements it created and then generously scattered into space. The Wolf-Rayet star WR124 was seen surrounded by a beautiful, glowing shroud of its own making. Webb captured a stunning image of this rare and massive star, which is in the final quiet stage before it will likely become a supernova. The image shows the star surrounded by a clumpy, radiant, and beautiful nebula of gas and dust. This is material that the star itself has cast off in its unstable and powerful old age. It is a quiet and serene portrait of a star in its final, glorious, and unsettled moments. This star is on the verge of becoming a supernova. A Wolf-Rayet star is a star that has burned through its hydrogen and is now in a later, more chaotic stage of its life. It is a quiet and beautiful moment of cosmic anticipation. The star we see in the Webb image is a ticking clock, a serene and majestic object that is in the final, peaceful prelude to its own grand and spectacular finale. The nebula around it is made of material the star has gently cast off in its old age. The beautiful glowing cloud surrounding WR124 is not the result of an explosion, but of the star's powerful stellar winds. Over thousands of years, the star has been peacefully and steadily blowing its outer layers off into space. The surrounding nebula is a quiet and beautiful history of the star's recent past, a serene and dusty chronicle written in the language of its own substance. The death of a star is not an end, but a quiet act of cosmic recycling. Whether a star dies in the gentle puff of a planetary nebula or the grand explosion of a supernova, the ultimate result is the same. The heavy elements that it spent its entire life patiently forging, the carbon, the oxygen, the iron, are returned to the vast interstellar medium. It is a profound and beautiful act of generosity, a quiet and peaceful bequeathal to the future of the cosmos. Webb can study the dust created by dying stars. The telescope's infrared vision is perfectly suited to studying the formation of cosmic dust. It can see the gentle, warm glow of dust grains condensing in the cooling outflows of dying stars. This dust, which contains all the heavy elements necessary for planets and for life, is one of the most important and serene ingredients in the cosmic recipe, and Webb is seeing its quiet creation for the very first time. The Southern Ring Nebula is like a quiet, cosmic flower blooming for just a few thousand years. The beauty of a planetary nebula is a fleeting and gentle thing on cosmic timescales. The glowing shells of gas will continue to expand and cool, and over a period of just a few tens of thousands of years, they will become so diffuse that they will fade away completely, merging invisibly back into the quiet darkness of the interstellar medium. We are fortunate to be alive at a moment when we can see this particular serene and beautiful flower in its full bloom. The different shells of gas show that the star died in a series of gentle, periodic pulses. Webb's incredibly detailed image of the Southern Ring Nebula revealed that the expanding cloud is not a single, smooth shell. Instead, it is a series of beautiful concentric rings. This is a quiet and profound clue telling us that the star did not shed its outer layers all at once, but in a series of gentle, periodic pulses, a slow and rhythmic series of final, soft, and peaceful exhalations. Studying dying stars helps us understand the quiet, eventual fate of our own sun. Our sun is a middle-aged star living a quiet and stable life. But one day, in about 5 billion years, it too will enter its old age. By studying other stars like the one in the Southern Ring Nebula, we are getting a gentle and beautiful preview of our own sun's distant, serene, and peaceful future. We are quietly reading the final chapter of our own star's long and beautiful story. The atmosphere of a planet 1,000 light-years away has been found to contain water. One of the most exciting capabilities of the Webb telescope is its ability to study the atmospheres of planets orbiting other stars, known as exoplanets. In one of its first major discoveries in this field, Webb looked at a hot gas giant named JWST-96b and found the clear, unambiguous, and quiet chemical signature of water vapor in its air. Webb studied the exoplanet JWST-96b as it passed in front of its star. The method Webb uses to study atmospheres is beautiful and serene in its simplicity. It waits for a planet to pass in front of its host star in an event called a transit. A tiny fraction of the starlight will then filter through the planet's thin atmospheric veil. By analyzing this filtered starlight, the telescope can determine what gases are present in that distant, quiet sky. The starlight filtering through the planet's air revealed the quiet signature of clouds, haze, and water vapor. The data from JWST-96b was not just a simple detection of water. The detailed spectrum revealed a much more complex and peaceful picture. It showed evidence for a hazy, misty atmosphere with clouds of water vapor drifting through it. It was our first gentle, and incredibly detailed look at the weather on a world over 1,000 light-years from home. This was the most detailed spectrum of an exoplanet's atmosphere ever captured. The quiet precision of the James Webb Space Telescope opened a new era in the study of other worlds. The graph of the light from WSP-96b's atmosphere, with its clear peaks and valleys corresponding to water, was a beautiful and serene confirmation that we now have the technology to read the chemical stories of distant alien skies. Webb has taken the first ever direct image of an exoplanet. While most exoplanets are detected indirectly, Webb has the remarkable and quiet ability to photograph some of them directly. It captured a serene and beautiful image of a gas giant planet named SHIP 65426b. The planet appears as a tiny, faint, and peaceful dot of light, a single, quiet pixel, next to its much brighter host star. The telescope used a special coronagraph to block out the bright light of the host star. To take a direct picture of a planet is incredibly difficult because the light from its star is 1 billion times brighter. Webb uses an instrument called a coronagraph, which is a tiny, precise mask that is placed in the telescope's light path to block out the glare of the star. It is like creating a quiet, perfect, and artificial eclipse, allowing the faint, gentle glow of the nearby planet to become visible. Webb has studied the 7 rocky, Earth-sized planets of the TRAPPIST-1 system. This is one of the most exciting planetary systems ever discovered, a compact family of 7 Earth-sized worlds orbiting a small, cool star. Several of these planets are in the habitable zone, the quiet, temperate region where liquid water could potentially exist. Webb is patiently and peacefully studying each of these worlds, looking for any sign of an atmosphere. The telescope has confirmed that one of these planets, TRAPPIST-1b, has no significant atmosphere. In one of its first results from this system, Webb observed the innermost planet as it passed behind its star. By measuring the drop in infrared light, the telescope could calculate the planet's temperature. It found the planet to be a very hot, bare rock, with no sign of a significant atmosphere that would redistribute heat. It is a quiet and serene but important piece of the puzzle. The telescope has studied the composition of asteroids in our solar system's main belt. Webb has turned its powerful spectroscopic gaze upon the small, quiet worlds of the asteroid belt. In its very first attempt, it looked at a main belt asteroid and found the clear and gentle chemical fingerprint of water ice on its surface. This is a quiet and profound clue that supports the theory that Earth's water may have been delivered by these small, rocky bodies in the early history of the solar system. Webb observed the DART mission when a spacecraft intentionally collided with an asteroid. As part of humanity's first test of a planetary defense system, the Webb telescope, along with Hubble, was used to observe the moment the DART spacecraft impacted the small asteroid Dimorphos. It was a quiet and unique opportunity to see how the surface of an asteroid behaves when it is disturbed. It saw a beautiful, silent plume of debris ejected from the asteroid after the impact. Webb's time-lapse images of the DART impact are serene and breathtaking. They show a bright, concentrated core of ejected material with long, beautiful, and gently curved streamers of dust and rock expanding outwards into the quiet darkness of space. The telescope's observations helped scientists to understand the nature of the asteroid's surface and the surprising efficiency of the impact. The telescope is studying the Kuiper Belt, the quiet and icy region beyond Neptune. This is the third and most distant zone of our solar system, a vast and silent realm of countless small frozen bodies. These are the pristine and peaceful remnants from the formation of our solar system. Webb's incredible sensitivity is being used to study the composition of these quiet, icy worlds for the first time, giving us a gentle glimpse into the cold, deep freeze storage of our solar system's history. Webb has studied the atmosphere of Saturn's moon, Titan. The telescope has captured beautiful and serene images of Titan, the only moon in our solar system with a thick and hazy atmosphere. Its infrared vision can peer through the haze and see the surface, but it is also perfectly suited to studying the atmosphere itself. Its images have clearly tracked the slow, gentle movement of bright clouds across the moon's northern hemisphere. Webb has even studied the thin, quiet atmosphere of Mars. While we have many orbiters and rovers at Mars, the Webb telescope offers a unique and peaceful perspective. It can see the entire sunlit side of the planet at once. This allows it to study large-scale phenomena like global dust storms or the subtle changes in the entire planet's atmosphere throughout its seasons, providing a serene and beautiful context for the more detailed local measurements being made on the surface. The telescope can study comets as they pass through our solar system. Webb is a powerful tool for studying these quiet, icy visitors from the outer solar system. As a comet gets closer to the Sun, its ice turns to gas, creating a beautiful, glowing coma and tail. Webb spectrographs can analyze the chemical composition of this gas with incredible precision, telling us what these ancient and peaceful snowballs are made of. Webb has seen the water vapor plume from Saturn's icy moon, Enceladus. In a truly spectacular and serene observation, the Webb telescope recently imaged a colossal plume of water vapor erupting from the south pole of Enceladus. The plume was seen to extend for thousands of miles into space, a vast and gentle geyser of water being blasted out from a hidden subterranean ocean. This plume is believed to erupt from a salty ocean hidden beneath the moon's ice. The discovery of this plume is one of the most exciting in all of planetary science. It is direct and beautiful evidence for a vast liquid water ocean hidden beneath the moon's serene, icy crust. The water is kept liquid by the gentle tidal heating from Saturn's immense gravity. It is a quiet and beautiful glimpse into a hidden, secret, and potentially life-bearing world right in our own solar system. This quiet glimpse showed a plume extending almost 6,000 miles. The plume Webb observed was not a small jet, but a vast and gentle fountain, stretching for a distance that is almost as long as the entire continent of Africa. It is a testament to the immense power and activity hidden beneath the quiet, placid, icy surface of this small moon. It is a serene and beautiful exhalation from a living, breathing world. Webb is a powerful tool for exploring our own quiet, cosmic backyard. While its views of the distant universe are profound, Webb's new perspectives on the familiar planets, moons and asteroids of our own solar system are just as beautiful and serene. It is a quiet and gentle reminder that our own home is a place of deep and wonderful mysteries, with new layers of beauty waiting to be revealed. It reveals a new layer of serene beauty in the familiar worlds we thought we knew well. To see the faint rings of Jupiter, the bright clouds of Neptune, or the vast plume of Enceladus is to see our own solar system with new and peaceful eyes. The telescope is not just discovering new things, it is also deepening our appreciation for the quiet and gentle beauty of the things we have known for a long time. Even our own solar system is filled with quiet, gentle mysteries. From the origins of our water to the possibility of a hidden ocean on an icy moon, our own neighborhood is a place of profound and beautiful questions. The James Webb Space Telescope is a quiet and serene key, perfectly designed to help us gently unlock the answers to some of these most peaceful and important of mysteries. The telescope saw a beautiful, silent plume of debris ejected from an asteroid after a human spacecraft collided with it. As part of the DART mission, humanity's first test of a planetary defense system, the James Webb Space Telescope turned its quiet gaze to the moment of impact. The images it sent back were serene and breathtaking. They showed the small asteroid, Dimorphos, and from it, a vast, complex and beautiful plume of dust and rock blossoming into the silent darkness of space. The collision was not a violent, fiery explosion, but a gentle, kinetic touch that released a flower of dust. Webb's observations, taken over several hours, showed this plume of debris expanding and being gracefully swept back by the gentle pressure of the sunlight, a quiet and beautiful cosmic weather vane. The telescope is studying the Kuiper Belt, the quiet and icy region beyond Neptune. This is the third and most distant zone of our solar system, a vast and silent realm of countless small, frozen bodies that are the pristine, peaceful remnants from the formation of our solar system. These objects are incredibly faint and cold, making them almost impossible to study from Earth. Webb's incredible sensitivity is now allowing us to analyze the composition of these quiet, icy worlds for the first time, giving us a gentle glimpse into the cold, deep freeze storage of our solar system's 4.5 billion-year-old history. It is a quiet and gentle form of cosmic archaeology in our own backyard. Webb has studied the atmosphere of Saturn's moon, Titan, seeing gentle clouds drift across its hazy sky. Titan is a world shrouded in a thick, orange, nitrogen-rich haze, making its surface a deep mystery. Webb's infrared vision, however, can peer through this haze to see the moon's surface and, more importantly, to track the weather in its atmosphere. The telescope has captured beautiful and serene time-lapse images showing bright, gentle clouds of condensed methane drifting across the moon's northern hemisphere, a quiet and familiar weather pattern happening on a deeply alien and peaceful world. Webb has even studied the thin, quiet atmosphere of Mars. While we have a fleet of rovers and orbiters at the Red Planet, the James Webb Space Telescope offers a unique and peaceful perspective. Because it is so far away, it can see the entire sunlit face of Mars at once, something no orbiter can do. This allows it to study large-scale global phenomena with serene clarity, such as the subtle changes in the entire planet's temperature throughout its seasons, or the gentle onset of a planet-encircling dust storm. It provides a quiet, global context for the more intimate stories being told by the rovers on the ground. The telescope can study comets as they pass through our solar system, analyzing the water in their silent tails. Webb recently studied a rare main belt comet, a quiet, icy body that orbits within the asteroid belt. Using its powerful spectrographs, it was able to analyze the cloud of gas, or coma, surrounding the comet's nucleus. For the first time, it detected the clear and gentle chemical signature of water vapor. This observation provides quiet, direct evidence that water ice from the primordial solar system was preserved in these regions, supporting the beautiful idea that Earth's oceans may have been delivered by similar quiet, icy bodies long ago. Webb has seen the water vapor plume from Saturn's icy moon, Enceladus, with breathtaking clarity. In a truly spectacular and serene observation, the telescope imaged a colossal plume of water vapor erupting from the south pole of Enceladus. The plume was seen to extend for thousands of miles into space, a vast and gentle geyser of water being blasted out from a hidden subterranean ocean. This plume feeds Saturn's faint E-ring, and Webb could see the beautiful, donut-shaped torus of water vapor that encircles the planet, a quiet and misty halo created by this tiny, active moon. This plume is believed to erupt from a salty ocean hidden beneath the moon's ice. The discovery of this plume is one of the most exciting in all of planetary science. It is direct and beautiful evidence for a vast, liquid water ocean hidden beneath the moon's serene, icy crust. The water is kept liquid by the gentle, tidal heating from Saturn's immense gravity. The plume contains not just water, but salts and simple organic molecules, all the quiet, gentle ingredients that are necessary for life. It is a serene and beautiful glimpse into a hidden, secret, and potentially living world right in our own solar system. Webb is a powerful tool for exploring our own quiet, cosmic backyard. While its views of the distant universe are profound, Webb's new perspectives on the familiar planets, moons, and asteroids of our own solar system are just as beautiful and serene. It is a quiet and gentle reminder that our own home is a place of deep and wonderful mysteries, with new layers of beauty waiting to be revealed by looking at them in a new and different kind of light. It reveals a new layer of serene beauty in the familiar worlds we thought we knew well. To see the faint rings of Jupiter as clear bright hoops, to see the weather on Neptune for the first time in decades, or to see a plume of water from a tiny moon stretch for thousands of miles is to see our solar system with new and peaceful eyes. The telescope is not just discovering new things, it is deepening our quiet appreciation for the gentle and intricate beauty of the things we have known for a long time. Webb has found surprisingly complex molecules in the dust clouds between stars. Peering into a cold, dark molecular cloud where a new star is just beginning to form, the telescope's spectrographs detected the clear and quiet signatures of complex organic molecules. These include things like methanol, but also more complex compounds that are the gentle chemical precursors to the building blocks of life. These molecules are forming in the cold, silent darkness of space long before planets even exist. The quiet, empty spaces between the stars may be gentle chemical kitchens. The telescope is finding that the universe may be more hospitable to life than we thought. The discovery of water and complex organic molecules in so many different and quiet places, from the atmospheres of giant planets to the cold, dark clouds where stars are born, paints a beautiful and serene picture. It suggests that the basic, gentle ingredients for life are not rare, but are common and widespread throughout the cosmos. The universe, it seems, is quietly and patiently seeding itself with possibility. It has found failed star, known as brown dwarfs, with surprisingly rich atmospheres. Brown dwarfs are quiet and lonely objects, more massive than a planet, but not massive enough to ignite as a star. Webb has been able to study their atmospheres in incredible detail. It has found evidence for clouds made of silicates, like sand, and a host of complex molecules. These quiet, forgotten objects are not just simple cooling embers. They are complex worlds with their own serene and beautiful weather and chemistry. A strange question mark-shaped object was found in the deep field images. In one of Webb's most profound images of the distant universe, keen-eyed observers noticed a tiny, faint object in the background that is perfectly shaped like a question mark. This is almost certainly not an alien message, but a beautiful and serene cosmic coincidence. It is likely the chance alignment of 2 or 3 distant galaxies that are in the slow, quiet process of merging, their gravitational interaction pulling them into this familiar and evocative shape. It is the universe gently and quietly asking its own beautiful questions. The telescope has found that early galaxies were flatter and more elongated than previously believed. Instead of being the small, clumpy, spherical objects that theories predicted, many of the first galaxies seen by Webb are surprisingly flat and shaped like long, thin disks or even cigars. This quiet and gentle discovery suggests that the early formation of galaxies may have been more orderly, happening along the great, silent filaments of the cosmic web, which channeled the gas into these serene and elongated shapes. Webb is challenging some of our most fundamental ideas about how the cosmos works. From the surprising maturity of the first galaxies to the complex chemistry of distant worlds, the discoveries from the Webb telescope are not just adding details to our knowledge, they are gently and quietly rewriting some of its most fundamental chapters. It is a beautiful and serene scientific revolution happening not with a bang, but with the quiet and patient accumulation of new and wondrous light. Every new image is a quiet invitation to ask new questions. The beauty of the Webb telescope is that its discoveries often lead to more questions than answers. Each serene and beautiful image of a previously unseen phenomenon is a gentle and quiet prompt, inviting scientists and all of humanity to wonder, to theorize, and to continue the peaceful and endless journey of exploration. The universe, as seen by Webb, is a place of infinite and gentle mystery. The telescope has seen a star system with a strange, square-shaped nebula around it. One of Webb's most puzzling and beautiful images is of a binary star system surrounded by a series of perfectly concentric, geometric, and distinctly square-shaped shells of gas and dust. This serene and unexpected pattern is a profound mystery. It is thought to be related to the way the two stars in the central binary are interacting and shedding their material, but the details are still unknown. It is a quiet and gentle piece of cosmic art, a serene and perfect sculpture of unknown origin. This serene and geometric shape is a profound and beautiful mystery. The universe we are used to is filled with spirals and spheres, the natural shapes of gravity and rotation. To find a structure so regular and so rectilinear is a quiet and beautiful shock. It is a gentle reminder that the cosmos is capable of producing forms of serene and ordered beauty that go far beyond our own limited expectations. The universe is more creative and surprising than our theories can predict. Time and again, the discoveries from the James Webb Space Telescope have shown us that the real universe is more beautiful, more complex, and more serene than our mathematical models had led us to believe. It is a quiet and humbling lesson. The universe is the ultimate artist, and our science is just our patient and peaceful attempt to understand its beautiful and gentle brushstrokes. Webb has discovered tiny, young galaxies that are producing stars at an incredible rate. In the early universe, Webb has found a population of small, compact galaxies that are glowing with the intense, brilliant light of furious starbirth. Nicknamed sparkler galaxies, these small systems are serene and beautiful crucibles of creation, converting their gas into new stars with a quiet and astonishing efficiency that is rarely seen in the universe today. Webb has found signs of an ancient cosmic river of gas flowing between early galaxies. The telescope has observed a long, thin, and serene filament of hydrogen gas, stretching for millions of light years and connecting a chain of young galaxies. This is direct, beautiful evidence for the cold accretion model of galaxy growth. The idea that early galaxies were not just built by messy mergers, but were also quietly and peacefully fed by these vast, gentle and life-giving rivers of primordial gas. This quiet, negative result is an important clue in the search for life. Finding out that a planet has no atmosphere is just as scientifically valuable as finding one that does. It helps astronomers to refine their models of which planets are most likely to be habitable. The search for other worlds is a slow, quiet, and methodical process of elimination, a gentle and peaceful process of asking questions and listening carefully to the silent answers the universe provides. Webb has detected carbon dioxide in the atmosphere of another exoplanet. On a gas giant planet named WSP-39b, the telescope made the first ever definitive detection of carbon dioxide in an exoplanet's atmosphere. This common and important molecule is a key tracer of a planet's history and composition. This quiet and gentle discovery was a major step forward in our ability to perform detailed chemical analyses of worlds' light years. Away, the telescope has even seen clouds made of sand on a distant brown dwarf. Webb studied an object called VHS 1256b, which is a brown dwarf or a failed star. Its detailed atmospheric spectrum revealed the clear and unmistakable signature of fine silicate particles, essentially tiny grains of sand or dust. This means that the clouds on this strange and beautiful world are not made of water, but of swirling, hot, and vaporized rock. It is a quiet and serene weather system of a kind we can barely imagine. Webb is a quiet and powerful tool for remote geology on other worlds. The discovery of silicate clouds is a beautiful reminder that Webb is not just an astronomy tool. By analyzing the chemical composition of a planet's atmosphere, it can tell us about the minerals and rocks that may exist on its surface or deep within its interior. It is a peaceful and gentle way of studying the geology of a planet that we will never be able to visit. It can measure the temperature of distant planets. By looking at the infrared light, or heat, that a planet emits, the Webb telescope can act as a long-distance thermometer. It can measure the temperature of a planet's day side and its night side, telling us how well its atmosphere circulates heat. This quiet and gentle measurement is a crucial clue in determining whether a planet might have a climate that is stable and peaceful enough for life. The planet K2-18b, which may have a water ocean, was found to have methane and carbon dioxide in its air. This was one of Webb's most exciting and gentle discoveries. This exoplanet is a sub-Neptune that lies in the habitable zone of its star. Webb's analysis of its atmosphere found these carbon-bearing molecules, which on Earth are associated with life. The data also hinted at the presence of a molecule that, on Earth, is only produced by marine life. It is a quiet, tantalizing, and beautiful hint of a potentially living, breathing world. This suggests the planet could have a water cycle, a quiet and familiar process on a distant world. The specific mix of gases found in the atmosphere of K2-18b is consistent with the presence of a liquid water ocean covering the planet's surface. It is a quiet and profound possibility. The gentle and familiar rhythm of water evaporating from an ocean, forming clouds, and raining back down might be happening right now on a serene and distant world. Billions of miles away, the search for life is a slow, patient, and quiet process of gathering clues. The James Webb Space Telescope will likely not find a single, definitive proof of alien life. Instead, its job is to be a patient and quiet detective. It will gather many small, gentle, and circumstantial clues: the presence of water, a temperate climate, a specific mix of gases. It is a slow and peaceful process of building a scientific case, a serene and beautiful search for our place in the quiet cosmos. Webb is looking for biosignatures, gentle chemical hints that could be caused by living things. A biosignature is a chemical fingerprint that is difficult to explain without the presence of life. A combination of gases like oxygen and methane in the same atmosphere, for example, would be a powerful and quiet clue, as these gases normally destroy each other. Webb is patiently and peacefully searching the skies for just such a serene and beautiful chemical imbalance. An exoplanet's atmosphere is a thin, fragile, and quiet veil of gas. The layer of air around a planet is incredibly thin compared to the size of the planet itself. Yet this delicate and gentle veil holds the entire story of the planet's climate, its weather, and potentially its life. By studying the light that passes through this quiet, fragile layer, the Webb telescope is learning to read the most profound and beautiful stories in the universe. Every exoplanet is a new, quiet, and unique puzzle. Webb is showing us that the family of planets in our galaxy is more diverse and surprising than we ever imagined. There are hot Jupiters, water worlds, lava planets, and worlds with clouds of sand. Each new observation reveals a new and unique planetary personality, a quiet and serene puzzle of chemistry and physics that scientists can now peacefully begin to solve. Jupiter was seen with a new and quiet clarity. The James Webb Space Telescope has not only looked at the distant universe, it has also turned its golden eye to our own familiar neighbors. Its images of Jupiter are breathtaking, revealing the planet's turbulent atmosphere with a level of detail we have never seen before. The serene and beautiful image shows the delicate, wispy structure of its clouds and the immense, swirling patterns of its storms. The telescope captured stunning images of Jupiter's auroras glowing over its poles. Just like on Earth, Jupiter has powerful auroras beautiful and silent light shows caused by particles from the Sun interacting with its magnetic field. Webb's infrared view captured these auroras with stunning clarity, showing them as bright, ethereal rings of light, glowing serenely in the darkness over the planet's north and south poles. Webb also saw Jupiter's faint and dusty rings, which are normally almost invisible. Jupiter has a ring system, much like Saturn's, but it is so faint and tenuous that it is almost impossible to see. Webb's incredible sensitivity allowed it to capture a clear and beautiful image of these quiet, ghostly rings, along with the faint inner halo of dust surrounding the planet. It is a quiet and gentle reminder that even the biggest and brightest objects in our solar system have their own faint and secret beauties. The Great Red Spot, a storm larger than our entire planet, appeared as a soft, white oval. In the colors of infrared light that Webb sees, Jupiter's iconic Great Red Spot looks very different. The high-altitude hazes that cover the storm are very reflective in the infrared, and so the giant churning storm appears as a bright, calm, and serene white oval against the darker bands of the planet's clouds. It is a peaceful and quiet new perspective on the solar system's most famous and long-lived storm. Tiny, faint moons could be seen orbiting the giant planet. In its breathtaking portrait of Jupiter, Webb's sensitivity was so great that it not only captured the planet and its rings, but also some of its smallest and faintest moons, like Amalthea and Adrastea. They appear as tiny, quiet, and peaceful points of light, silent and faithful companions on their long, eternal journey around the giant planet. Webb captured a stunning, serene image of Neptune and its rings. For the first time since the Voyager 2 flyby in 1989, we have a clear and detailed image of the rings of the most distant planet in our solar system. Webb's image of Neptune is a quiet and ghostly masterpiece, showing the planet as a deep, dark orb encircled by several narrow, bright, and incredibly delicate rings of ice and dust. For the first time in 30 years, we could see Neptune's faint, dusty rings in clear detail. The rings of Neptune are so faint and so distant that they have been almost impossible to study from Earth. Webb's clear and steady view from its quiet orbit at L2 has given us a new and breathtakingly serene look at these beautiful and mysterious structures. We can see both the bright, narrow rings and the fainter, more diffuse sheets of dust that lie between them. It is a quiet and beautiful new portrait of a world on the edge of our solar system. The planet itself was a beautiful, pearly white, with bright clouds of methane ice. In Webb's infrared view, the methane gas that gives Neptune its blue color in visible light absorbs most of the sunlight, making the planet appear quite dark. However, high-altitude clouds of frozen methane ice are very reflective, and they appear as bright, beautiful, and serene white patches against the dark globe. It is a quiet and ghostly view of the weather on a distant ice giant. Webb has also studied the strange, tilted world of Uranus. The telescope has taken beautiful and serene new images of our solar system's other ice giant. These images clearly show the planet's faint inner and outer rings, as well as a bright, glowing polar cap. This quiet and serene feature is a seasonal haze that forms over the planet's north pole, as it is bathed in continuous sunlight during its long, slow summer. The telescope is helping to measure the expansion rate of the universe with new precision. By observing special types of variable stars in distant galaxies, Webb is providing new and more accurate measurements of the Hubble constant, the number that tells us how fast the universe is expanding. This quiet and painstaking work is helping to solve one of the biggest and most peaceful puzzles in all of modern cosmology. Webb has found that some early galaxies are surrounded by a faint, green halo of oxygen. In some of the most distant galaxies ever seen, the telescope has detected the faint, gentle, and unexpected glow of ionized oxygen gas in a vast halo surrounding the galaxy. This serene greenish aura is a quiet and beautiful clue, telling us about how the very first heavy elements produced by the first stars were being gently expelled into the space around them. The telescope has seen gravitational arcs, the light of a distant galaxy bent into a perfect, gentle curve. In many of its deep-field images, Webb has captured the beautiful and serene phenomenon of strong gravitational lensing. The immense gravity of a foreground galaxy cluster acts as a natural telescope, bending and magnifying the light from a much more distant galaxy behind it, stretching its image into a long, thin, and graceful arc of light. The quiet precision of the telescope's mirror is almost beyond comprehension. Each of the 18 mirror segments was polished so perfectly that if one were scaled up to the size of the entire United States, the largest imperfection would be only a few inches high. This serene and beautiful level of smoothness is what allows the telescope to focus the faint, ancient light of the cosmos into the sharpest and most profound images we have ever seen. Webb has found that dust can form much earlier in the universe than we thought. The telescope has detected large amounts of dust in some of the most ancient galaxies. This was a quiet surprise, as it was thought that the process of creating cosmic dust from the elements forged in stars would be a very slow and patient one. The universe, it seems, was in a gentle hurry to create the quiet, dusty nurseries where future stars would be born. The telescope is a quiet and powerful testament to human curiosity. The James Webb Space Telescope exists for no other reason than our deep and peaceful desire to understand where we came from and what our place is in the cosmos. It is a monumental and serene machine built not for profit or for power, but for pure, gentle, and quiet discovery. The telescope is a journey of quiet and peaceful revelation. Each new image, each new spectrum, is a soft and gentle unveiling of another of the universe's secrets. It is not a loud or sudden process, but a slow, methodical, and serene one. We are quietly and peacefully drawing back a curtain that has been closed since the beginning of time. Each new discovery from the telescope is a new, serene, and beautiful verse in the poem of the cosmos. The story of the universe is a grand and beautiful one, and the James Webb Space Telescope is our most powerful and eloquent narrator. It is providing us with new lines, new stanzas, and new chapters, all written in a quiet and gentle language of infrared light. Each new image from the telescope is a new, serene and beautiful page in the story of the cosmos. The book of the universe is vast and ancient, and for most of history, we have only been able to read a few of its words. The James Webb Space Telescope has given us the ability to turn to the very first page and to begin to quietly and peacefully read the story right from its beautiful, serene, and gentle beginning. And so, our quiet journey with the golden eye of the James Webb Space Telescope comes to a soft and gentle close. We have drifted back to the very dawn of time, and we have floated through the beautiful, serene landscapes where new stars are being born. The echoes of this ancient light and these new discoveries can now begin to soften and fade, leaving only a deep and profound sense of peace in their wake. It is time to let it all go. We have wandered through the first galaxies, seen the weather on distant worlds, and witnessed the quiet, graceful end of a star's long life. We have felt the deep and patient rhythm of the cosmos, a universe that is more beautiful, more orderly, and more surprising than we ever imagined. We have seen that even the grandest stories can be told in the gentlest of whispers. Let the feeling of this vast and quiet history be a deep comfort to you now. The universe that the Webb telescope sees is the very same universe that you are a part of. The ancient starlight it captures is the ancestor of the very light that warms your world. The elements it sees in distant nebulae are the same elements that make up your body. You are a quiet, and beautiful part of this grand and unfolding cosmic story. And now, as you drift down into the soft and welcoming depths of sleep, there is nothing left to do. Let these vast images of nebulae and galaxies become soft and distant, like clouds in a dreamy sky. Allow your mind to become as quiet and peaceful as that silent point in space, a million miles from home, where the great telescope keeps its patient watch. Your only task now is to rest, to let go, and to join the serene, sleeping state of the cosmos. May your dreams be as deep and quiet as the spaces between the first stars. Good night. The telescope has observed a star that is inexplicably dimming and brightening. Webb has been used to study strange and variable stars, like the one known as Tabby's star. Its incredible precision allows it to monitor the star's light for the tiniest of dips, helping astronomers to solve the quiet and gentle mystery of what might be orbiting the star and blocking its light. Each observation is a quiet and peaceful clue in a long and fascinating stellar detective story. Webb has found that the dust in the early universe is different from the dust we see today. By studying the infrared light from the most ancient galaxies, the telescope is learning about the composition of the very first cosmic dust. It seems that this early dust was made of different materials and had different properties than the familiar dust that fills our own galaxy. It is a quiet and gentle discovery that tells us that the very chemistry of the universe has been slowly and peacefully evolving over billions of years. The telescope is a quiet and powerful tool for solving the universe's oldest riddles. From the nature of the first stars to the origin of the chemical elements that make life possible, the James Webb Space Telescope was designed to address the most fundamental and peaceful questions in astronomy. Each image and each spectrum it takes is a quiet and beautiful piece of a grand and serene puzzle that we are, for the first time, beginning to see in its entirety. It is a journey of quiet and peaceful discovery. The story of the James Webb Space Telescope is not one of loud bangs and sudden revelations. It is a story of patient observation, gentle analysis, and the slow, quiet, and beautiful unfolding of a new and deeper understanding of the cosmos. It is a serene and peaceful expansion of our cosmic consciousness. A beautiful six-spiked star is a signature of a Webb image. In every image of a star taken by the telescope, the star appears not as a simple dot, but as a beautiful and serene six-pointed starburst. This is not a natural phenomenon, but a gentle artifact of the telescope's design. The 6 points are created by the diffraction of light around the edges of Webb's 18 hexagonal mirror segments and the struts that hold its secondary mirror. It is the quiet and beautiful signature of the telescope itself, its gentle fingerprint on every piece of light it touches. Webb has observed a proto-cluster of galaxies, a supercluster in its infancy. The telescope has peered back in time to see a dense and busy region of the early universe, where hundreds of galaxies are all beginning to fall together under their mutual gravity. We are seeing the quiet and serene birth of one of the largest structures in the entire cosmos, a gentle and beautiful glimpse into the ancient construction of the cosmic web. The telescope has found that supermassive black holes existed very early in the universe. Webb has detected the telltale light of active supermassive black holes in galaxies that are over 13 billion light-years away. This is a profound and quiet puzzle. It is not clear how these black holes could have grown to be so massive so quickly in the young universe. It is another serene and gentle mystery that the telescope has presented to us. Webb can study the faint zodiacal light of our own solar system. Even when it is looking at the most distant objects, the telescope must see through the faint, gentle glow of our own solar system's dust cloud. This zodiacal light, which we can sometimes see as a faint pyramid of light after sunset, is the sunlight reflecting off of countless tiny dust particles orbiting the sun. Webb is creating a beautiful and serene new map of this quiet, local, and dusty environment. The telescope's instruments are so sensitive they can be affected by the solar wind. The gentle but persistent stream of particles from our sun, the solar wind, can exert a tiny pressure on the telescope's vast sun shield. This can create tiny, quiet vibrations that the telescope's exquisitely sensitive instruments must be carefully programmed to account for. It is a quiet and beautiful dance between the gentle forces of the cosmos and the serene precision of human engineering. Webb has found that the centers of some early galaxies are intensely blue. This is a surprising and quiet discovery. The blue color indicates a burst of intense star formation happening right at the galaxy's core, without the presence of a large, older bulge of stars that we see in galaxies today. It suggests that the first galaxies grew in a different and more peaceful way, from the inside out. The telescope's data is made available to scientists all over the world. The James Webb Space Telescope is a mission for all of humanity. The vast and beautiful streams of data it collects are placed in a public archive, allowing any astronomer anywhere in the world to access them and make their own quiet and peaceful discoveries. It is a beautiful and serene example of global scientific cooperation. Webb has revealed the quiet turbulence in the atmosphere of a hot gas giant. By observing an exoplanet over a long period, the telescope was able to detect subtle changes in its atmospheric spectrum. This was the first time we have been able to directly observe the effects of weather and atmospheric chemistry changing on a planet outside our solar system. It is a quiet and gentle glimpse into the dynamic and perhaps even stormy skies of a distant, peaceful world. The telescope is finding cosmic noon was even more brilliant than we thought. The period about 11 billion years ago, known as cosmic noon, was the time when star formation in the universe was at its peak. Webb's observations of this era are revealing a universe that was filled with incredibly luminous and dusty galaxies, shining with a serene and gentle intensity that was even greater than our previous estimates. Webb can see the faint, extended halos of galaxies with new clarity. Galaxies are not just the bright disks of stars that we see, they are embedded in much larger, more diffuse, and almost invisible halos of ancient stars and dark matter. Webb's incredible sensitivity is allowing us to see the faint, serene, and gentle glow of these halos for the first time, revealing the true, vast, and quiet extent of these galactic islands. The telescope has found evidence of merging black holes in the early universe. In a distant, ancient galaxy, Webb saw the telltale signs of two supermassive black holes that were in the final quiet stages of spiraling into each other. We are seeing a glimpse of the serene and powerful process by which the largest black holes in the universe were built, a slow and gentle dance of two immense gravitational wells. Webb is a quiet and powerful complement to other telescopes, not a replacement. The James Webb Space Telescope sees the universe in a different kind of light than telescopes like Hubble. By combining their observations, Hubble's visible light and Webb's infrared, we can get a much more complete, beautiful, and serene picture of the cosmos. They are two different and peaceful sets of eyes working together to give us a single, deeper vision. The telescope has seen a globular cluster of stars in the process of forming. These are ancient, dense, and spherical collections of hundreds of thousands of stars. Webb has peered into a distant galaxy and seen a dense, compact region that appears to be a globular cluster in its very infancy. We are getting a quiet and beautiful glimpse into the serene birth of one of the oldest and most mysterious types of objects in the universe. Webb has found that the first galaxies may have been powered by stars, not black holes. It has long been a quiet debate whether the intense light from the first galaxies came primarily from star formation or from active black holes at their centers. Webb's early observations suggest that in the very earliest times, the light was dominated by the serene and gentle glow of countless young, Hot stars. The telescope is so stable it can hold its gaze on a single, quiet point for days. To create its famous deep-field images, the telescope must stare, motionless, at a single, tiny, and seemingly empty patch of the sky for many hours or even days. Its pointing stability is so precise it is like being able to hold a laser pointer, steady on a single small coin from a distance of many miles. This quiet and serene stability is the key to its ability to see the faintest and most distant things in the universe. Webb has found a tiny brown dwarf that is the faintest free-floating object ever seen. This quiet and lonely object, not much larger than Jupiter but adrift in the space between the stars, is so cool and dim that no other telescope could see it. Its discovery by Webb is a testament to the telescope's profound sensitivity, its ability to find the smallest, quietest, and most gentle needles in the vast cosmic haystack.